This is Official Nerd Business.
Hello nerd boys and girls, welcome back to our Euler and Python series. This is episode 10, and for episode 10 I have something special to show you. In fact, we're gonna take a swing at problem number 10, of course. But because we kind of went overboard on problem number 7, this one's pretty trivial. So let's have a look. As usual, I have created the docstring at the top with the title, with the parameter that we want to put in here, a tag, of which I could use more, but only one really applies here. And the description: the sum of the primes below 10 is 2 plus 3 plus 5 plus 7, 17. Find the sum of all the primes below 2 million. Below how much again? 2 million. As you can see, that's the default value for our one parameter. And like I said before, this is kind of easy once we, if we use the library that we've created before with the primesieve in it. So again, boilerplate code here, and this is the one attempt at solving this problem. I simply retrieve a list of primes from our Euler module, which is imported as E here, and I use an inbuilt Python function to sum everything up in this list and return it, and the return value gets either printed up here or printed by the main program. So if we were to run that main program, here we are. I'd like to see problem number 10, please, with the default parameter. There is our answer, and it took us almost half a second for all the primes up to 2 million. That's pretty fast, and this answer is correct. I can guarantee that if you enter this over at Project Euler, you will get the green check mark. So that was kind of simple and not really the bang you'd want to make on your 10th episode. So I did some additional stuff. As we can see here, here's a function that we haven't seen before. So if we take a look at our Euler library, here is our primes list method, and I've created this function so that we no longer have to call the sieve method directly and then look into this variable. I've placed underscores before these names of both the function and the variable up here to indicate that we shouldn't really be working with these directly. And now that I have created this primes list, we no longer have to work with them directly. So what does it do? I've added a bit of documentation string here. The primes list receives a lower and an upper bound. Does one basic check to see if they were given in the incorrect order, and switches them around if that happened. Then it calls the sieve on the upper bound to ensure that we've always got these numbers. We get a list of primes, and we only include primes onto this list from our now sieved and initialized primes array. Let's see this bit of syntax. We take every prime on this list and we name it P for the time being, and we want to put it P on the list if, and here's a filter criterion, if P is between the bounds that we've set. This is called, and I'm not entirely sure if we've seen it before, this is called a list comprehension. So this describes an operation, in this case a filter, but we could do anything on this bit. This describes building up a list from an existing list. So here's the list, here's an element of this list. We could do any kind of operation on the element before it's placed on the list, and here is a filter criterion determining if we do or do not want it on the list. Then there's the variable overshoot upper bound. What this does, if we would just give an upper bound and tell it not to overshoot, say we have we give it the number 20. 20 itself is not prime, of course, so it would give us all the primes up to 19, and then return that list, which is fine for most cases, but sometimes you want the guarantee that whatever upper bound you provided is included on the list itself. So with overshoot it would go on to 23, ensuring that our upper bound is at least between the top two values on the list. Well, this bit of code takes care of exactly that. It gets us the highest prime value, it tries to increase it until the sieve hits another prime, then it ensures that we get that one prime. It can blindly take the last prime on the range because this call to the sieve might not do anything if we've already initialized it to a higher prime. So this specifically looks at whatever prime is the maximum element of this list and takes the one prime after it. And all of that is described in this standard piece of docstring here. I've also created the same docstring for the prime factors function that we already had, so it just adds a bit of documentation. So that's the changes on the libeuler library, which allow us to do this, so that we no longer have to work with the sieve and the primes list in the module directly. This covers it all up for us. And to recap a couple of things, since this is our 10th episode, let's run through a couple of things we've picked up. We've seen how to create docstrings, which are both capable of being assigned to a variable just as a block of text, and are used in Python to describe a lot of things, as long as they are at the top of your file or function. We've seen how to use imports. This imports math, does not alias it, and imports everything that is in the math library. This imports the timing module, and it gives it the alias tx, so any function we want to use from time needs to be prefixed with tx dot. And this is an import statement that we haven't seen yet. This specifies a module, and from that module we import only a given function. So now we can use the primes list. Primes list will take care of the prime sieve, etc. We are only allowed to use primes list, and it doesn't need a prefix in this case. We've learned how to create functions. So here's the sum function with some argument, and it simply returns 1. Function doesn't, it could, but it's not very efficient to have it print anything to screen, so it returns something. And we could call that function here and then use the return value for whatever purpose we see fit. We've also seen that if a Python file is run directly, it will just run any code that's not indented. Of course, we've seen that indentation is very important to Python code, as we can see in this function and in this if statement. And we've seen that this is a good way to group up code that just needs to run in this file if this file is called directly. We can initialize string variables. We can even use special characters for line breaks. We can initialize numbers, and here again is a list comprehension. We create the range from 0 to but not including 10, and we take every element from that range into our list. And if we were to execute this particular file, we would see that it simply prints 3 variables with a tab in between. Now it does enter a line break here in our execution, and that's because we told it to some text /n for new line with a new line. Then a tab, believe me, it's there for our numerical variable, and another tab going into this list with items 0 up to and including 9. So that really covers the basics. As you can see, because we went a bit overboard on problem number 7 with our prime sieve, problem number 10 is kind of trivial. There is an overview for problem 10 which describes the prime sieve, so might have jumped the gun there a little bit. So yeah, check that out. It even improves the prime sieve that we have, because we haven't corrected yet for the fact that we don't need to test even numbers. We also test odd numbers. There's ways around that which are described in the overview. Maybe we'll do that for the next trivial challenge we hit. Not entirely sure if that's still a thing up 10, but we'll see. I've added a bit to the library that at least I'm using. I hope you find that useful, and we've seen this little recap. I will see you again for problem number 11. Thanks for watching this video on Official Nerd Business. Don't forget to like and subscribe and click the bell icon. Did we discuss everything you wanted to hear, or did we miss anything? Any topics you want to hear in O&B? Leave your thoughts in the comments. See you next time.